This is how to wire a single-phase motor, the finished diagram, right here on screen. One motor, two windings, a capacitor, and just four terminals in the box. Line and neutral come in. The capacitor sits across two of the terminals, and the direction it spins is decided by one pair of wires. It looks fiddly. It is not. Let me rewind and build it up from nothing, one piece at a time, so every terminal finally makes sense. Start with the thing that makes a single-phase motor different. It has two windings, not one. The first is the main winding, also called the run winding. It is the heavy one, and once the motor is spinning, it does all the work. The second is the auxiliary winding, also called the start winding. It is thinner. It sits at 90 degrees to the main winding inside the motor, and it is only there to get things moving. Here is the problem it solves. Feed a single winding from single-phase power, and the magnetic field it makes just pulses back and forth in one line. It pushes the rotor, but it does not tell it which way to turn. So the motor sits there, humming, and never starts. Two windings, offset in space, is the fix. But on its own, that is still not enough. The trick is a phase shift. The two windings are apart in space, 90 degrees, physically. To make the field actually rotate and drag the rotor around, we also need the current in the start winding to be out of step in time with the current in the main winding. Give the start winding a current that leads or lags the main winding, and the two pulsing fields combine into one smooth field that sweeps around the inside of the motor, a rotating field. The rotor chases it, and away it goes. So how do we shift the current in time? We put a capacitor in series with the start winding. A capacitor makes the current through it lead the voltage, so the start winding current arrives early, out of step with the main winding, and that is exactly the phase shift we needed. That single part is why almost every single-phase motor has a capacitor bolted to the side. Quick note before the wiring. Every diagram in this video is drawn in a free editor that runs right in your browser, CircuitDiagramMaker.app. No install, no sign up. Open it in a second tab and follow along. So let us talk about that capacitor because there is more than one kind. A start capacitor is big, and only in the circuit for a second or two while the motor spins up. It gives a strong kick, then it is switched out. A run capacitor is smaller, and it stays connected the whole time the motor runs. It gives a gentler shift, but it also smooths the motor and improves efficiency. That gives you three common wiring types. A PSC motor, permanent split capacitor, uses just one run capacitor, always in circuit. Simple, quiet, common in fans. A capacitor start motor uses one big start capacitor for the kick, then drops it out. And a capacitor start, capacitor run motor has both, a start capacitor for torque and a run capacitor that stays in for the hardest starting loads. Read the capacitor to read the motor. If a start capacitor is only in for a second, something has to switch it out. That job belongs to the centrifugal switch. It is a mechanical switch on the motor shaft. At rest and at low speed, it is closed, so the start winding and its capacitor are connected and the motor gets its kick. As the rotor speeds up, spring-loaded weights fly outward, and at around 75% of full speed, they snap the switch open. That drops the start winding and the start capacitor right out of the circuit. From then on, the motor runs on the main winding alone. It is also why you sometimes hear a click as a motor gets up to speed. That is the centrifugal switch letting go. On a permanent split capacitor motor, there is no centrifugal switch at all, because the single run capacitor is meant to stay in forever. Now, the part you actually wire, the terminal box. Open a standard single-phase motor and you find four terminals. The main winding ends are marked U1 and U2. The start winding ends are marked Z1 and Z2. For leads, two windings. Here is the standard connection. Bridge U1 and Z1 together and bring your line, the live, to that junction. Bridge U2 and Z2 together on the other side and bring your neutral there. That puts both windings across the supply. Then the capacitor goes in series with the start winding, wired between the two start terminals or between the start winding and one side of the line, depending on your motor's plate. The motor's own wiring diagram printed inside the terminal box lid, is the final word. Always follow it. Line and neutral to the mains. Capacitor on the start winding. Earth to the frame. That is the whole connection. Want it to spin the other way? You do not swap line and neutral. That does nothing. To reverse a single-phase motor, you swap the two ends of the start winding relative to the main winding. Take Z1 and Z2 and flip them over. That reverses the direction of the phase shift, so the rotating field sweeps the other way, and the motor turns the other way. Main winding untouched, start winding reversed. That is the whole reversal. And never skip the earth. The green and yellow conductor bonds to the motor frame at the marked earth point. If a winding ever fails to the case, that earth is what trips your protection instead of putting the frame live. On a metal frame motor, it is not optional. Here is a real motor wiring diagram, open straight in the editor. The whole circuit sits on one clean sheet, the supply coming in through the switch and the protection, out to the motor and the earth on the frame. Follow any wire, end to end, and nothing is hidden. That is what a clear drawing gives you. And in a moment, I will show you where the full single-phase version lies. And here is something a plain drawing cannot do. Check it with a real simulation. I will open a ready-made motor starter template, already wired. There is a genuine circuit engine inside the page. Hit Simulate, run the DC analysis, and real voltages and currents land right on the wires. If a connection were wrong, the numbers would tell you before a single wire got crimped. That is a check no paper diagram can give you. That exact single-phase motor diagram lives on the site, free to open, print, or copy as your own starting point. There is a whole library of motor and control diagrams alongside it, and a full symbol reference, all linked in the description. Grab the one closest to your motor and edit from there. So that is how to wire single-phase motor start to finish. Two windings, main and start, offset inside the motor. A capacitor in series with the start winding to shift the current and spin up a rotating field. A centrifugal switch to drop the start winding out at speed. Terminals U1, U2 on the main, Z1, Z2 on the start. Line and neutral across both, capacitor on the start. Swap the start, leads to reverse. And always earth the frame. Open the free editor, grab the single-phase motor template, and wire your own. The link is in the description. Subscribe for a new wiring diagram explained every week, and I will see you in the next one.